Hare Krishna friends, welcome to my YouTube channel at the rate 𝗏𝗏𝗏. Today I am going to make a video on BFD. This will be my first video on YouTube. BFD is nothing but a device which is widely used in industrial application to control the speed of three-phase induction motor. First of all, we discuss that why do we need to control the speed of three-phase induction motor. These various types of machines are operated by using high rating three-phase induction motor. So the load requires variable speed. So we have to control the speed of three-phase induction motor. There are three methods are used to control the speed of three-phase induction motor. Number one is stator side control. In stator side control, we using three methods. Number one, by changing the magnitude of supply voltage or by changing the magnitude of supply frequency, and third one is by increasing number of poles, because by the formula of the speed of three-phase induction motor, that is Ns is equal to 120F upon P. It means Ns is inversely proportional to the number of poles. Second one is rotor side control. This method is used only for slip ring induction motor, in which first one is by changing the magnitude of rotor resistance. Second one is by injecting the EMF in rotor circuit. Third is cascade speed control method. So let's start one by one. Number one, supply voltage control method for speed control of three-phase induction motor. In this method, to change the magnitude of voltage, supply voltage, we use transformer. Since it affects the speed, this is the another method of speed control of three-phase induction motor. By the formula, you can easily understand that the speed of three-phase induction motor is directly proportional to supply frequency. In India, we are using standard value of supply frequency is 50 Hz. If we want to variable speed by changing the supply frequency, we have need of frequency converter or prime mover. But the drawback of the system is that we can convert the magnitude of supply frequency at a certain limit. For this purpose, a BFD, a very important device which is used in industrial application. By changing number of poles, the formula Ns is equal to 120F by P indicates that Ns is inversely proportional to number of poles. It means when we increase number of poles, the speed of three-phase induction motor decreases. In this method, tappings of different number of poles are provided, by which we can get variable speed. The drawback of this method of speed control of three-phase induction motor is that we cannot get the speed in between 2 to 4 poles. So this method is used in very limited place in industry. Oftenly by using this method, we can get 2 to 3 speeds of three-phase induction motor. Suppose that P is equal to 2, then the speed of three-phase induction motor will be 3000 RPM. If P is equal to 4, then the speed of motor will be 1500 RPM. If P is equal to 6, then the speed of three-phase induction motor 1000 RPM. Second method of speed control of three-phase induction motor is rotor side control. This method is only used for slip ring induction motor. Let's start. In standard still condition, S is equal to R2. At running condition, S is equal to R2 upon X2. Value of slip can be changed by changing the value of rotor resistance, so that the speed of three-phase induction motor becomes changed. By the formula, you can see NR is equal to NS 1 minus S RPM. Suppose that for a 4-pole motor, speed of induction motor is 1500 RPM. Then case first, If the value of s is equal to 0.02, then the speed of router will be 1470 rpm. Okay, second, if the value of slip is 0.04, then the rotor speed will be 1440 rpm. But the drawback of this method is that external resistance can be added in only case of slip ring induction motor. We cannot connect external resistance in case of squirrel cage induction motor. So that this method of speed control of three-phase induction motor is only used with the slip ring rotor type three-phase induction motor. If the direction of stator field and the injected EMF is same, then effective value of speed increases. If the direction of injected EMF and stator field is opposite, then the effective speed decreases. The drawback of the system is that we have required separately low frequency voltage source, so the system becomes very costly. The system is used in industry at a certain place. This is third and last method of speed control of three-phase induction motor, in which two motors are used. First one always is slip ring induction motor, and second one it may be slip ring rotor type induction motor or squirrel cage rotor type induction motor. We can get the variable speed in a step or smoothly. The disadvantage of this type of method is that we have to use two motors separately, and the performance of the system is very low. There are two types of cascading, that is cumulative cascade and differential cascade.
तो फ्रेंड्स जल्दी से ऐसी ही वीडियो के लिए जल्दी से चैनल को सब्सक्राइब कर दीजिए और नीचे जो बेल का आइकन है उस पर भी प्रेस कर दीजिए ऑल के लिए, क्योंकि जब भी हम अपनी ऐसी नॉलेज वाली वीडियो को अपलोड करें तो आपको ऑटोमेटेड नोटिफिकेशन चला जाए और आप जल्दी से जल्दी उस वीडियो को देख के कुछ ना कुछ एक्स्ट्रा नॉलेज ले लें। तो थैंक्स फॉर वॉचिंग, मिलते हैं नेक्स्ट वीडियो में।